Natural logarithmic function. Again, the inverse of ln of x is e to the x, and ln of x is continuous and is increasing everywhere. The limit as x approaches negative infinity of ln of x doesn't exist. If you notice with my red line, it's I can't go to, it's not keep on going to infinity, it just keeps on going all the way down to negative infinity, so it's not approaching anything. It just doesn't exist. No, it never even gets to the negative numbers. The limit as x approaches infinity, so as I move to the right, as x is increasing to infinity, y is increasing to infinity. And so you must know the following log properties. Ln of 1 is 0. Ln of 1 is 0, so the y-coordinate at 1 is 0. Ln of a times b is equal to ln of a plus ln of b. Ln of a divided by b is ln of a minus b. Ln of a to the n is equal to n ln of a. And e to the ln of x is x, and ln of e to the x is x. And so the most important part that we're really going to deal with is the derivative of ln's. And so when we're talking about the derivative of ln, we're going to take the derivative of whatever. We're going to put the derivative of ln of something. So whatever ln of my something is. So here's my, I'll put a little box for my something. So we're going to have the derivative, I'll do something prime, over whatever something is. And so that's the pattern for my ln. Ln of what, that goes in the denominator, whatever that what is, and that and its derivative is going to go in the numerator. So let's look at several examples. Alright, we're going to find our derivatives. Part 1. V of t is equal to ln of t squared plus 3. Well, here is, I'm taking the derivative of something. There's my something. And so the way it works is I'm going to, what's in my box, so this will be a of t is equal to, and whatever is in my box, I'm going to rewrite it in the denominator. And so I'm going to rewrite t squared plus 3. And then whatever's in my box, I'm going to put its derivative on top. So the derivative of t squared plus 3 is 2t. Part B, again, the derivative for finding the derivative for y equals 4 to the x times ln of 5x to the 4th. And so what we're going to have, what you see is I have the product rule. Here's my first, 4x. My second is ln of 5x. Well, my ln has an inside, so I'm going to have that little box thing going on again. So when we take our derivatives, we have y prime, and so we'll do the derivative of the first. So the derivative of 4x is 4 times the second. And we'll put in our 5x to the 4th in there. And we're going to add it to the first, there's a 4x, times the derivative of the second. Well, the derivative of the second is we have that box thing going on again. So what was in my box? Ln of something. What was ln of 5x to the 4th? And so whatever, now we're going to take the derivative of whatever ln of something. So the derivative of what was in my box, 5x to the 4th, is equal to 20x to the 3rd. And we'll just stop right there. Alright, now we have h of x is equal to ln of tan of x divided by 3 pi. And so again, here's my, I'm going to put a little box around ln of something. That's what's going to go in my denominator. And so when we find our derivative, so h prime of x is equal to, I'm going to back that up and make it put a little bit lower. Oops. H prime of x is equal to, and so again I'm going to put that box down there, and we're going to fill that in. And so inside my box I'm going to write that tan x divided by 3 pi and now I'm going to take its derivative on top. Well, 3 pi in the denominator is my coefficient, so I'm going to do 1 over 3 pi. Okay, that's my coefficient. And so now I'm going to multiply that by the derivative of my tangent. Well, derivative of tangent is secant squared of x. And so that's my derivative. Number 2, if f of x is equal to ln of x plus 4 plus e to the negative 3x, then find f prime of 0. Again, I'm going to create a box around what ln is, and so it's ln of x plus 4 plus e to the negative 3x. And so when I take my derivative, I'm going to go put, there's my box, and so I'm going to repeat what was in my ln box. So in my ln it was x plus 4 plus e to the negative 3x. And so now I'm going to take the derivative of what's in my box. So derivative of x is 1, derivative of 4 goes away. And derivative of e to a power, remember, is I'm going to, or for the last video, I'm going to rewrite it. And I'm going to multiply it by the derivative of my power. Derivative of my power is going to be times negative 3. And so now we're going to just plug in 0 into my derivative, find that value. So we're going to find f prime of 0 is equal to, so again we're going to have 1 plus e, well if I plug in 0 in for x here, I'm going to have e to the 0, because negative 3 times 0 is 0, so I have e to the 0 times negative 3 divided by, and I'm going to plug in 0 in for x, so 0 plus 4 plus e, and again if I plug in 0 into this x down here, I'm going to have negative 3 times 0, which is 0, so again e to the 0. So if I was going to simplify this, I'm going to have 1 plus, well, e to the 0 is 1. This is equal to 1. So 1 times negative 3 is negative 3. I'm left with 0 plus 4 is 4. And again, e to the 0 really is just 1, so I have 4 plus 1. So this is equal to negative 2 over 5. Number 3, write an equation for the line tangent to the graph of f of x is equal to negative 2 plus ln of x squared at x equals 1. And again, I have an ln, so I'm going to put a little box around my x squared. And so we're talking about the tangent line. And so let's go ahead and plug in to find the y-coordinate. F of 1 is equal to negative 2 plus ln of 1 squared. Well, 1 squared is just 1. The part of the property that I told you that you need to know is ln of 1 is equal to 0. So we have negative 2 plus 0, which is negative 2. That's my y-coordinate. So now let's go ahead and take our derivative. Derivative of negative 2 goes away. And then the derivative ln of x is, I'm going to do that box, so I have a box around x squared, so that's where my x squared is going to go in the denominator. And then I'm going to take the derivative of my box, so derivative of x squared is 2x. And so if I was going to simplify this, I have 2x over x squared. Well, 2x over x squared, these x's are going to cancel. And I'm really just left with 2 over x. And this will help me be able to find f prime of 1. So f prime of 1 is equal to 2 over x, which is, we're plugging in 1, which is equal to 2. So that's my m. And so now I'm ready to write my tangent line. And so my tangent line is going to be y plus 2 is equal to 2 times x minus 1. Number 4. Find the slope of the line normal to the graph of y equals 2 times ln of secant x at x is equal to pi over 4. So let's first find our y coordinate. So y coordinate is going to be 2 ln, and I'm going to rewrite secant as 1 over cosine because that's what it means. 1 over cosine of pi over 4. Well, cosine of pi over 4 is root 2 over 2. So the inverse of that, so root 2 over 2 is, I can also say that's 1 over square root of 2. Well, the reciprocal of that is going to be root 2. So secant of pi over 4 is root 2. So I have 2 ln of root 2. Well, according to my derivative rules I show above, is this 2 actually, this 2 actually can come over here and be a power for my root 2. So I'm going to rewrite that. So this is equal to ln of root 2 squared. That's what it means when that 2 is in front of the ln. That means whatever ln of whatever is going to be squared. Well, if I square square root, it means it just goes away. So ultimately, this is equal to ln of 2. Okay, whatever that decimal value is. So that is my y coordinate. So now let's go ahead and find our derivative. So y prime is equal to, and again, we're talking about, it's the derivative, it's the ln of something. Well, I'm going to create that little box around that secant. And so I have y prime, my coefficient is 2, so I'm just going to multiply by 2 in the numerator. And I'm going to create that little box in the denominator, so I'm going to fill that in. So that's going to be my secant x. And the derivative of secant is secant tangent. So now, if you notice, I have secant divided by secant. I have secant divided by secant. Well, these guys just cancel. So what I really have is equal to 2 tangent of my x-coordinate. So we're looking at y prime of pi over 4 which is equal to 2 times tangent of pi over 4. Well, tangent is sine over cosine, so sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. So tangent of pi over 4 is really just 1, because we're talking about my slope. So if we're having a 45-degree angle, the slope of that 45-degree angle is 1 over 1. So really you have tangent of pi over 4 is 1. So you have 2 times 1, which is equal to 2. And so now we can just write our, that's the derivative, that's my m. My perpendicular m, because we're talking about the normal line, is equal to negative 1 over 2. So my normal line is y minus ln of 2, whatever that decimal value is equal to my perpendicular slope, negative 1/2, times x minus the angle that I've been plugging in, which is pi over